Hello again, Dr. Vaughn. This is our third and final installment in this ongoing problem number 10 from your Chapter 15 assignment. As you can see, I have most of this top part done now. I'm going to walk you through a couple of things. So where we left off last time, first of all, these two p-values down here, I filled in one of them. You still have one more to go. But I wanted to point out that this 0.0303, you just need to use that right-tailed distribution, t.dis.rt. And then you're still going to use the 7 degrees of freedom, the same thing that you did for the intercept and the x1 and the x2. You're using 7 degrees of freedom in each case. And the only reason I'm using the RT here is because I have a positive t-value. I'm computing the area to the right and then doubling it, as opposed to in the intercept case, I had a negative t-value, so I used the left tail and then doubled it, which means I just left off the RT. All right, so that's how you can go about finding these p-values. Down here, we already did this in the last video. Now let's talk about the regression statistics. All right, so first of all, the R-squared value. So the R-squared value, I don't know if you can see up in my browser window up here, is just the quotient of the sum of the squares of the regression divided by the sum of the squares of the total. So I'm going to take the 1.76209 and divide by 1.88. And I get 0.93728, and that's my R squared that goes in the second box. The multiple R, which is in the first box, is just the square root of R squared. So just take the square root equals SQRT if you're using Excel, and then that gives you the R, which is the top box here. The adjusted R squared, there's a formula. You can get it out of your book. It's 1 minus, parentheses, 1 minus the R squared, times, and then this is the degrees of freedom total divided by the degrees of freedom for the residual. So 9/7 in my case, right? 1 minus R squared times degrees of freedom total divided by degrees of freedom of the residual. That gives me the adjusted R squared, and that's what goes in the third box over here. We already filled in the observations. That's just, 9 plus 1 is 10. And finally, for the standard error, this one, you look online, your book doesn't really give you a very good formula for it, but it's way, way, way easier than any of the stuff that you'll spend a lot of time looking around. This standard error for your regression statistics is really just the square root of the mean square of your residual. So in the case that we have over here, if you take square root of this big number, 338, whatever, you'll get the 6198. So in our case, all I need to do is take the square root of the mean square residual, which is this number, 0.01684, right? And you'll see that I kind of have that typed over here, square root of, and then I copied that number and just took the square root, and that is the standard error, and that's how I was able to fill in and get this last question correct. So once you have all of this filled out, now I'm just going to look at the overall significance, okay, the F value, that is less than P, and so there is a significant relationship. Did the estimated regression provide a good fit? You're going to look at the R squared value and determine whether it's bigger than or less than 0.5, and then you're going to use the t-test to test these hypotheses. You already have the p-values. You're really just going to compare the p-values to your alpha value in order to reach the rejection decisions down over here. So again, you still have a few things to fill out, but none of them are calculations. I think that I've taken you all the way through the calculations. And with that, I'm going to sign off for tonight anyway. Please let me know if I can be of any more assistance, and I'll talk to you again soon.